Okay, so in today's video, we're going to talk about what are the New York City Mechanical Code regulations on fire dampers, smoke dampers, and fire smoke dampers. Then we'll discuss what is a fire damper and smoke damper and how do these function. Then we'll talk about the New York City Mechanical Code regulations on intakes as well as exhaust openings. Okay, so the New York City Mechanical Code version 2022 is the most current code at the time of this recording. And you could just search New York City Building Code and you could click this link here and you could see the latest version is 2022. Previously it was 2014. So when you click on this, you'll see a list of the different code sections, and we'll just click a mechanical code. And the section that is relevant to fire dampers would be here in duct systems. So that section is 607, which is basically right here. Or you could just quickly do a Control F and you could just search for 607. And you can also find it that way as well. So in here, you'll see the fire dampers are required where ducts penetrate fire resistance rated assemblies that are required to be protected. So some walls have to be a certain rating, a minimum fire rating. It could be 1 hour, it could be 2 hours or more. And whenever duct passes through these fire rated assemblies, you need a fire damper. And generally, rooms that require fire ratings are at exterior walls, boiler rooms, roofs, corridors, shafts, and tenant separating walls. So these are some of the walls that require some sort of fire resistance rating. So if you look here, this is generally what a shaft looks like. It's just a clear path where you could run pipes or ducts, and it's rated. It could have a 1 hour rating, or it could be more than a 1 hour rating. This is another example of how the shaft is actually constructed. So basically they'll put in some sort of reinforcement walls, and then they'll pour concrete and they'll get something such as this. This is what a shaft is. It basically connects multiple floors with a fire resistance rated assembly. And if you have a floor that is fire rated and you have pipe penetration such as in this picture here, you need to fire stop the space that's around the piping with some sort of fire resistance rated material. In this case, it's that orange reddish type of sealant that you see here. So we'll first look at what the definition of a shaft is, and if you want to know, you could basically find it in the New York City Building Code. So it's not the mechanical code that we're looking at now, which was here. We're actually looking at the Building Code, and the Building Code is a place where you can go to the definition section to see what the different terms are if you ever needed to, as well as what the different occupancy classifications are if you ever needed to as well, because most of these codes depend on the type of occupancy. And if you want to figure out what type of occupancy your building is, you could figure that out by reading this section here, which is chapter 3. To get more information on what a shaft is as defined by the New York City Building Code, you go into this chapter here, which is 7, Fire and Smoke Protection Features. And here we can just type in shaft. Okay, and you'll see shaft enclosures are fire resistance rating of fire barrier separating building areas from a shaft shall comply with section 713.4. And 713.4 is here. And it basically states shaft enclosures shall have a fire resistance rating of not less than 2 hours where penetrating 3 stories or more, and not less than 1 hour where penetrating fewer than 3 stories. The number of stories connected by the shaft enclosure shall include any basements or cellars, but not any mezzanines. The shaft enclosure shall have a fire resistance rating not less than the floor assembly penetrated, but need not exceed 2 hours. Shaft enclosure shall meet the requirements of section 703.2.1. So I cut out that section talking about shafts and I placed it here. And I drew in basically 5 floors here. So if we were to draw a shaft that extended, basically started from the floor of the first floor and extended through the second floor, and the shaft was like this, it's basically just penetrating this one floor, which is labeled as 2. So in this case, this shaft rating would have to be just 1 hour, as it's penetrating fewer than 3 stories. So now if we extended it to the fourth floor, now we're penetrating third floor and second floor. So it still would be 1 hour since it's fewer than 3 stories. Now, once we penetrate this fourth floor to the fifth floor, now this whole shaft rating would have to be 2 hours, since we're penetrating these 3 floors here, which is the second, third, and fourth floor. All right, so the fire damper rating has to be according to table 607.3.2.1 in the mechanical code. And I placed that table right here. And you can see if the duct is penetrating a fire resistance rated assembly that is less than 3 hours, the minimum damper rating is 1.5 hours, and 3 hours or greater, the damper rating has to be a minimum of 3 hours. Before we were talking about fire dampers. Now for smoke dampers, which are a little bit different, they basically operate upon sensing some sort of smoke from a smoke detector. And once the smoke detector detects the smoke, it'll send an electrical signal to a actuator, which is just a motorized damper that'll close. And that's what a smoke damper is. A fire damper is something that just operates all mechanically, meaning that it has a fusible link. And when there's a fire, it melts that link and it basically unloads the fire damper and it closes it. And that's how a fire damper works. So a smoke damper is more electronic. A fire damper is purely mechanical, operated. So smoke dampers are generally required in public corridor penetrations and shaft penetrations. And there are some exceptions to this based on the code, and that's in section 607.5. So if you look at 607.5, it'll tell you where fire dampers, smoke dampers, or a combination of fire smoke dampers are required. So you can read this section to figure out all the areas where it is required and all the exceptions to those rules. So where both fire and smoke dampers are required, a combination fire smoke damper can be used. Where duct penetrates a non-fire rated floor, sometimes you still need to protect those penetrations. And if you look at 607.6.3, you will see that even for non-resistance rated floor assemblies, you also need some sort of protection according to this section here. So again, this is all part of the New York City Mechanical Code, so you can actually find this section in the New York City Mechanical Code right here, non-fire resistance rated floor assemblies, and the requirements where ducts are penetrating these non-fire resistance rated assemblies. So to go over this section here, you could see that duct systems constructed of approved materials that penetrate non-fire resistance rated floor assemblies shall be protected by any of the following methods. A shaft enclosure, like we discussed, which could be a 1 hour rating or 2 hour rating, depending on the amount of floors that are penetrated. A duct connects not more than 2 stories, and the annular space, which is basically the space between let's say, the duct that penetrates the floor and the floor itself. So that space is the annular space, is protected with an approved non-combustible material that resists the free passage of flame and the products of combustion. In floor assemblies composed of non-combustible material, a shaft shall not be required where the duct connects not more than 3 stories, which basically means that it's penetrating not more than 2 stories. The annular space around the penetrating duct is protected with an approved non-combustible material that resists the free passage of flame and the products of combustion, and a fire damper is installed at each floor line. And the exception to that is fire dampers are not required in ducts within an individual residential dwelling unit. Now, fire dampers also shall not be used in commercial kitchen type 1 exhaust. And type 1 just means that it has grease vapors going through it, which can be a fire hazard. And those type of kitchen hoods are considered type 1 exhaust systems. And the reason you are not allowed to put fire damper in a commercial kitchen is because if you do, that's a place where grease could collect on, and that would actually cause a fire hazard if the grease collects on the fire dampers. So that's why the code actually prohibits fire dampers from being installed inside of commercial type 1 exhaust systems. Also, it's prohibited in laundry exhaust for the reason that lint from the clothes can actually get caught in the fire dampers, and that could turn out to be a fire hazard. So the code prohibits fire dampers in laundry exhausts, and as well as combustion vents. And in combustion vents, these send out the byproducts of combustion for water heaters and boilers, as some appliances. So if you put a fire damper there and it accidentally closes, now you can't exhaust your combustion products, which could basically be very harmful if that combustion products comes back into the occupied space, where it could have some sort of carbon monoxide, which is harmful and could actually kill people. So these are some of the places where fire dampers are prohibited. Okay, so a fire barrier here is basically a wall that has a fire rating to it. So any ducts and air transfer openings, air transfer opening can just be a duct that is a short piece of duct that just kind of extends through a wall that may be full height. So if this is the floor and this is the ceiling, a transfer duct is a short piece of duct, that's just a few feet or so that extends past this wall that allows free transfer of air through the walls. That may be required for airflow in an HVAC system. So this section is just stating that ducts and air transfer openings, such as this one here, that penetrates a fire barrier needs to have a listed fire damper installed. And they also mention it shall not penetrate exit enclosures and exit passageways. And an exit enclosure is just a enclosed staircase. And also, if a duct or an air transfer opening penetrates a public corridor and horizontal exit wall, you also need a smoke damper listed here. Now, they also have some sort of exceptions that are listed in this section here. And sometimes I apply this exception here for some jobs where such walls are penetrated by ducted HVAC systems having a required fire resistance rating of 1 hour or less in other than Group H occupancies and are in buildings equipped throughout with an automatic sprinkler system in accordance with this section which deals with sprinkler systems. For the purposes of this exception, a ducted HVAC system shall be a duct system for the structure as the HVAC system. Such a duct system shall be constructed of sheet metal not less than 26 gauge. And the higher the gauge number, you're actually getting a thinner thickness of the steel or the metal. And the lower the gauge number, so if this was 24 gauge, the thickness actually increases. So it works the opposite way. So the lower the gauge, the thicker the metal. And shall be continuous from the air handling appliance or equipment to the air outlet and air inlet terminals. So in the New York City Building Code, they throw a couple terms around. One is fire barrier. You also see the term fire partition in the building code. And it appears that, these are pretty much similar. They both have some sort of fire resistance rating. But certain things are categorized as a fire barrier and certain things are categorized as a fire partition. You'll see section 707, it's the fire barriers section, and you can see here it lists different type of things such as shaft enclosures and exit passageways and horizontal exits. And if you want to see what these terms actually represent, you could go into the definition section of the building code to find out what these terms actually mean, if you wanted to find out more information on these terms. And if you scroll down, you'll see that there's a section 708, which is for fire partitions. So it seems to separate certain things between the two, but they both mean that it has some sort of fire rating and it's a wall rather than a horizontal assembly. So I list these two here. And, fire partition, it has to have a fire resistance rating of not less than 1 hour. And that's actually listed in this section here where it says, fire partitions shall have a fire resistance rating of not less than 1 hour. So a horizontal assembly is different from these fire partition and fire barrier since it is not a wall, it's a horizontal assembly. And there's a different section that deals with horizontal assemblies. So that section is Building Code BC 711, which talks about horizontal assemblies and the requirements for these type of assemblies. Another table I wanted to bring up is table 508.4. So this is a table that lists what type of fire rating separation is required based on the different occupancies that you're trying to separate. So if you have an A assembly, which stands for assembly, assembly occupancies can be for things like churches and restaurants. And if you were to separate an A from a, let's say, a R, R stands for residential buildings, you need basically a 1 or a 2 hour separation. So the S stands for, if you look down here, buildings equipped throughout with an automatic sprinkler system. And the NS basically stands for non-sprinkler buildings. So buildings not equipped throughout with an automatic sprinkler system. So as you can see here, if it's sprinkler, they require a less of a fire rating. And if there is no sprinkler protection, they want a higher fire resistance separation between these two occupancies. So I'm going to pick just an example of a building that has 2 residential units. It will be basically following this section here. So R separating another R. And if you look down here, it says N for both. And if you look down here, N stands for no separation is required. But if you look carefully, you'll see an A next to the R. So you have to kind of read all these small notations here. So A is listed here as saying see section 420. 420 means chapter 4. And if you look at section 420, it deals with the R occupancies 1, 2, and 3. And if you wanted to know what these represent, You could look in the occupancy section of the building code to see what these represent. And if you look here, separating walls, walls separating dwelling units in the same building, walls separating sleeping units in the same building, and walls separating dwelling units or sleeping units from other occupancies contiguous to them in the same building shall be constructed as fire barriers constructed in accordance with Section 707 and shall be at least 1 hour fire resistance rated. So you could see that if you have two different units in the same building, it has to be separated by a 1 hour rated wall. And the requirements for the horizontal separation is under this section here. And it states floor assemblies separating dwelling units in the same building, floor assemblies separating sleeping units in the same building, and floor assemblies separating dwelling units or sleeping units from other occupancies contiguous to them in the same building shall be constructed as horizontal assemblies in accordance with Section 711. So if you go back to 711, that's the horizontal assembly section. And if you look here, it basically shows you that for dwelling units and sleeping units, horizontal assemblies serving as dwelling or sleeping unit separation in accordance with Section 420.3, located in Group I1 and R occupancies, shall be not less than 1 hour fire resistance rated construction. So as you can see, it's very, the code is split up into so many different sections. And in order to get the entire code regulation for some type of job you're working on, can require you to jump around through different sections of the code just to get the information you need. So from all these different code sections, we can see that for a residential unit, you need a 1 hour separation at the walls and at the horizontal floors and ceilings that are separating two different residential units. And that is kind of the process you have to go through to figure out what the fire rating requirements are between the different occupancies. Or you can ask the architect what the fire ratings are for all the walls, floors, ceilings, and roofs. Now we're going to move on to exhaust systems, and we're going to first talk about closed dryer exhaust. And the section that deals with that is actually in the MC, which stands for Mechanical Code of New York City. And that's section 504. So to go there, to go to that section, you'll just go back to the New York City Code website, and under Mechanical Code, it would be under Chapter 5, which deals with exhaust systems. So we're going to look into this chapter right now. And, this is the section I want to talk about since it's very common to have closed dryer exhaust in a building. And some of the main points I want to talk about for a closed dryer exhaust is that fire dampers are actually prohibited, as well as combination fire smoke dampers. And any similar device that will obstruct the exhaust flow is listed right here as being prohibited in closed dryer exhaust ducts. And you have to make sure you have cleanouts at each vertical riser. So as let's say this is the dryer and the exhaust goes this way, and this is the roof. At this vertical rise here, you need to have a clean out right at this location, and that's to remove any lint that might build up. And also another section I want to point out is this here, and it basically states that dryer exhaust ducts for closed dryers shall terminate on the outside of the building. Single dryer installation shall be equipped with a backdraft damper. Multiple dryer installations, typical that you see in like a commercial laundromat, shall not have a backdraft damper, and screens shall not be installed at the duct terminations. Also, you cannot have any sheet metal screws or other fasteners that will obstruct the exhaust flow. Closed dryer exhaust ducts shall not be connected to vent connector, vent, or chimney. Closed dry exhaust ducts shall not extend into or through ducts or plenums. Okay, so most of this information here in this section is basically dealing with any type of obstruction that could collect lint and cause a fire hazard, as lint could catch on fire. So that's the reason they don't want any screws in ducts. They don't want any type of dampers typically, except for a single dryer installation where they do allow a backdraft damper. And also they don't want any fire dampers or combination fire smoke dampers on laundry exhaust systems. Okay, so now I want to show you some pictures of things we just spoke about. So the first one I want to talk about is what a flexible duct connector is. And that's basically this piece right here, which is connecting the HVAC equipment, which is this, to the duct. And it's flexible because the HVAC equipment is vibrating and rotating. And this flexible duct allows that vibration from occurring without transferring most of that vibration to the duct, which may cause a lot of noise issues. So you have this flexible duct connector. This right here is a fire damper. So this would slide inside of a duct. So the ducts would basically go this way, right? And this would slide right into the duct, right where it penetrates through the fire rated wall or horizontal assembly. And it has a fusible link, which is right here. And as there's a fire, this fusible link will melt, and this right here is a spring-loaded piece that once the fusible link melts, it will shut very quickly because it's spring-loaded with a lot of force. This right here is the access door, okay, to the fire damper, which will be located right at this penetration of this wall. So the fire damper would be located inside the duct, somewhere right here at the penetration. So once the fire damper closes, somebody can open up this access door by moving these clips, sliding this panel out, and then they could go in and reload this spring mechanism here and then put another fusible link in place. So typically these fire smoke dampers will be wired to a smoke detector somewhere near the smoke damper. And once this smoke detector is triggered, if there's smoke, then it'll automatically send a signal to the electronic controls that will basically turn this shaft and close the smoke damper inside the duct. This smoke detector can actually be a standalone system, or it could be part of a fire alarm system in the building. So that if the smoke detector goes off, it'll basically trigger the fire alarm system. And triggering the fire alarm system may trigger horns and strobes within the building, as well as automatically call the fire department through a central station, which is basically just a 24-hour surveillance company that will automatically send a signal to the fire department if the fire alarm panel is triggered. So once this smoke detector is activated and it activates the fire alarm system, then the fire alarm system will then send a signal to this smoke damper and basically turn this motor, this actuator, to turn the shaft that will then close the smoke damper inside. So this is typically how a smoke damper works. So a fire damper works all mechanically, just through heat, no electronics. And a smoke damper works through electronics. So if you have both a mechanical piece that basically will activate and shut the damper if there's a flame, and also you have that damper close electronically once a smoke is detected, then you have a combination fire smoke damper. So here is the access door, which is required for fire damper and smoke damper or fire smoke dampers for maintenance and replacement. And this is another picture of a fire smoke damper. Again, you see a different type of actuator here. This is the motor, and it spins this shaft, which goes in here. And as it's spinning, it basically opens up this damper right here. And also, there might be something that's thermally activated. So if there's a flame, it'll basically automatically shut this device here. Now here's the actuator for motorized operation of the smoke damper. Here is a picture of a flexible duct connector. So it's just another picture of this right here. So it could look like this. And here is a picture of flexible ducts here. So this would be the rigid duct, and these would be the flexible duct. So I just wanted to mention flexible ducts so you don't confuse it with flexible duct connectors, which represent this here. So these are a little bit different. Okay, now I want to talk about intake and exhaust requirements. And before I do that, I want to go over a couple of terms that will be needed when reading the code regulations on these items. So, I want to discuss habitable spaces, and there's also occupiable spaces. These are two different types of spaces, and the code defines habitable space as all rooms and spaces within a dwelling unit in Group R and I1, including bedrooms, living rooms, studies, recreation rooms, kitchens, dining rooms, and other similar spaces. All right, now there are some exceptions listed here that are within dwelling units and shall not be considered habitable spaces. These are dining space of 55 square feet or less, located off a living room, foyer, or kitchen, a kitchenette, bathroom, toilet room, laundry rooms, and corridor, passageway, or private hall, and a foyer used as an entrance hall in a dwelling unit, not exceeding 10% of the total floor area of the dwelling unit, or not exceeding 20% of the floor area of the dwelling unit, where every habitable room is at least 20% larger than the required minimum room size established by New York City Housing Maintenance Code. A kitchen is defined as a room with 80 square feet or more of floor area used for cooking. A kitchenette is a space with less than 80 square feet of floor area. Occupiable spaces are pretty much all spaces other than habitable spaces. So it's defined as a room or enclosed space other than habitable space designed for human occupancy or use in which individuals may remain for a period of time for rest, amusement, etc. Now, here's a diagram of different type of buildings based on the lot line. So the lot lines here are represented by these black lines here. And the lot line basically represents the ownership of that property. Okay, so we'll just go through the different types of buildings now. So the first one is an attached building. And these abut two side lot lines or is one of a row of abutting buildings, such as in this case here. Detached is when the building is completely separated on all four sides, from the lot line. Semi-detached, it's only connected to one lot line out of the four sides of a building. You also have a zero lot line building, which basically abuts one side lot line of a zoning lot and does not abut any other building on an adjoining zoning lot. So to do a quick recap, if a building is touching none of the four lot lines, it's considered a detached building. If the building is touching one out of the four lot lines, depending on whether the building is touching the adjacent building or not, in this case, it'll be called a semi-detached building or a zero lot line building. And if the building is touching two of the four lot lines, it's considered an attached building. So now let's go into talking about the intake outlets and some of the requirements for intakes. Section 401.4 of New York City Mechanical Code 2022 talks about the intake outlet regulations. So that section 401.4 can be found here. If you scroll all the way to the top, 401.4. So this chapter talks about the ventilation or the intake ventilations. Now this whole chapter you could basically read to get all the information you need, but I'm just gonna cover in this video some of the main points. So 401.2, the ventilation where it is required is in habitable and occupiable spaces shall be provided with ventilation in accordance with this section. Now, for every occupiable space shall be naturally ventilated in accordance with section 402 and mechanically exhausted in accordance with table 403.3.1.1, or mechanically ventilated in accordance with section 403. So whenever you see this section starting off with a 4, it means it's chapter 4 here. So the main idea here is that whenever you have an occupiable space, you can choose to be either naturally and mechanically ventilated. When you say exhausted here, it means also ventilated, because if you are to, if you have a space like this, and let's say you have an AC unit here, and the outside air basically pumps into this building. Okay, now let's say you have also an exhaust fan that's blowing the air out from the space like this. So if you're mechanically exhausting, it's very similar to mechanically supplying air, such as in this case, because you're in both cases you're introducing outside air into the space, but in one case you're forcing the air into the building, so the building is becoming positive pressure. And in the other case, whereas the exhaust system here, you're basically creating negative pressure. But in both cases, you're introducing outside air into the space. So in the positive pressure case, you're pumping air into the space. And in the exhaust, as the air is leaving the space, that air has to be made up with an equivalent amount from the outside. So it's actually going to be bringing in outside air into the building from the exhaust for the same amount of CFM that is being exhausted. And typically the outside air goes into the space through cracks in the windows in the construction of the building itself, or through doors that may be opened up, or just kind of through the undercuts of the door and the openings that are around the door. Now the next point, 2, all habitable spaces and occupiable spaces provided with air conditioning shall be mechanically ventilated in accordance with section 403. Every habitable space shall be naturally ventilated in accordance with 402. And when you look at 402, that's the section on natural ventilation. And basically it just says that it has to comply with chapter 12 of the New York City Mechanical Code. And if you look at section 402, that discusses natural ventilation of occupiable and habitable spaces. And it basically just states that it has to comply with chapter 12 of the New York City Building Code, not the Mechanical Code, which this is.